Okay, so today we're going to look at application of similar figures. And remember, for figures to be similar, they need to be increasing or decreasing by the same scale factor. So if I look at my first set of triangles, and this first problem was actually not in your notes. So if you could copy this first problem into your notes so you can follow along as I'm going through it. So the first triangle has side measurements of 3, 5, and 4, and the next triangle has measurements of 9, question mark, and 12. And to figure this out, we're going to figure out how much we're increasing from one triangle to the next. So if I look at side length 3, its corresponding side would be 9. And corresponding just means that it's the same side, just on a different shape or a different triangle. And to go from 3 to 9, I would need to multiply by 3, which means we have a scale factor of 3. The next side is 4 and 12. And to get from 4 to 12, we are also increasing by a scale factor of 3. 4 times 3 will give me 12. And lastly, I have a side measurement of 5, and we're trying to figure out what the question mark is. So since I multiplied by 3 on the other two measurements, I also need to multiply by 3 on this measurement. So 5 times 3 is going to give us 15. Which means that our missing side measurement was 15. All right, on the next problem, I have triangle ABC, and I'm comparing that to triangle XYZ. Now this one's a little bit tricky because these two triangles are not facing the same direction. Triangle XYZ has been rotated, so it's facing the opposite way. So I'm going to redraw that triangle so that we can see corresponding sides, and both triangles will then be facing the same way, right? So we want it in alphabetical order. So if I have A, B, C, and the A is starting at the top, that means in XYZ, the X should also be starting at the top, followed by Y, and then followed by Z. So XY is 3 inches. YZ is 4 inches, and XZ is 5 inches. Now these two triangles are facing the same direction. All right, so side AB has a measurement of 6 inches, and its corresponding side would be XY. Now to get from 6 to 3, it means that I am dividing by 2, or I am cutting this in half, or multiplying by a half. Our next measurement would be side AC, and that is 10, and I'm comparing that to XZ, which is 5. So again, I'm dividing that by 2, or I'm multiplying it by 1/2. It's 1/2 the size. And our last measurement, we have side N, and we are comparing that to 3 inches. So I need to figure out what divided by 2 is going to give me 3. And you should know that that's 6. So our missing side measurement is 6 inches. Next, we're going to look at some application problems. And these problems have to do with a shadow being cast. So it states at any given time of a day, if you are standing outside, the shadow you cast will be proportional to the shadows of other objects. So, if we want to know the height of a tall tree without climbing it, we can find that height by using other measurements. And the first example we have is a 5-foot tall person casts a shadow that is 8 feet long. If a tree casts a shadow that is 30 feet long, how tall is the tree? Okay, so we have a 5 foot tall person, and I can't draw, so don't mind my illustrations. So we have a 5 foot tall person, and they cast a shadow that is 8 feet long. All right, we have a tree, and the tree casts a shadow that is 30 feet long, and we are solving for the height here. We want to know how tall the tree is. Okay, so the corresponding sides that we have are 8 feet shadow and a 30-foot shadow. And if I'm going from 8 to 30, I have to figure out what I'm multiplying by. So 30 divided by 8 is going to give me 3.75. Now to figure out the height of the tree, since I increased by a scale factor of 3.75, I would multiply 5 times 3.75. And that would tell me that the tree is 18.75 feet tall. Our last problem states, you measure the mailbox in front of the school and find that it stands 3.5 feet tall and is casting a shadow of 2 feet. You want to find the height of the flagpole that is casting a shadow of 12 feet. Find the height of the flagpole. Okay, so we have a mailbox. Again, I can't draw. That looks more like a flag. All right, we have a mailbox and it's 3.5 feet tall. And it's casting a shadow of 2 feet. You want to find the height of the flagpole that is casting a shadow of 12 feet. So we have a flagpole, which looks the same as my mailbox, and it's casting a shadow of 12 feet. And we want to find what the height of the flagpole is. All right, so again, I'm going to look at my corresponding sides, and the measurements I have are 2 and 12. So to get from 2 to 12, I'm going to multiply by 6, which means I also have to multiply the other side by 6. So I'm going to say 3.5 times 6, and 3.5 times 6 is going to give you 21. So that means that the flagpole has a height of 21 feet.